This time we'll proceed to product of vectors. So hopefully you mastered already how to add vectors using component. Like adding vectors, vectors are not vectors are not ordinary numbers, so we cannot apply the direct addition of vectors. Like 3 plus vector A has magnitude of 3, vector B has magnitude of vector B has magnitude of 4. Then if we're going to add these two vectors, we'll have magnitude of 7. Not all the time it's 7, because we will consider the direction of each vector. So like product of vectors, or looking for the product or multiplying vectors, we cannot apply directly the ordinary multiplication method to vectors. Like vector A has magnitude 4 multiplied by vector B whose magnitude is 3, then 4 times 3 is 12. No, not all the time. Okay, we cannot do that. We cannot do that because vectors are not scalars. So we will define the two kinds of product of vectors. One is scalar dot product. Okay, from the word scalar, the product is scalar, and the other one vector cross product. So from the word vector, the product is vector. All right. So let's have first the scalar dot product. Okay, scalar dot product. Suppose we have two vectors here, vector A and vector B. The tails of these two vectors are at the same point, so they have common point, right? And there is angle between angle A and angle. There's angle between vector A and vector B. All right. So how will we define scalar dot product? Suppose these are the two vectors, vector A and vector B, right? And angle phi is the angle between vector A and vector B. Now, if I'm going to make a line from the tip of vector B perpendicular to vector A, all right? So from this point to that point is the x component of vector B. So there is projection of the component of vector B to the direction of vector A, right? And the other one, if I'll make a line from the tip of vector A perpendicular to vector B, right? So this is perpendicular. Then this line here is A cosine phi. Phi is the angle between vector A and vector B. All right. So there is component of vector A, okay, projected onto direction of vector B, right? This one, there is component of vector B projected onto direction of vector A. And this one, there is component of vector A projected onto direction of vector B. Okay? So what is the scalar dot product? Scalar dot product is a scalar, and it is defined as the dot product of two vectors is the magnitude of A times the magnitude of B cosine of angle phi. Angle phi is the angle between two vectors. All right, angle A, direct magnitude of vector A times the magnitude of vector B cosine of the angle between them. Okay, so again, this is B. So this is B cosine theta, which is the magnitude of vector B projected onto direction of A. We can also, there's an alternate way of defining the scalar dot product, that is the same given vectors. There is component of vector A projected onto the direction of vector B. Okay, so we have, let's go back in this case, the dot product of vector A and vector B is the projection of the component of vector B, which is B cosine phi, times the magnitude of vector A, which is A. So vector A dot vector B equals AB, magnitude of vector A times the magnitude of vector B cosine phi. Alright? So if we're going to consider the component of vector A onto projection of vector B, projected onto direction of vector B, then the scalar dot product, which is vector A dot vector B, is defined as the projection of vector A, which is the component of vector A that is projected onto the direction of vector B, which is A cosine phi, times the magnitude of vector B. So that's B. So still A, magnitude of A times magnitude B cosine phi. Okay, that's cosine phi. So again, we define scalar dot product as if given two vectors, vector A and vector B, and the angle between these two vectors is angle phi, then angle vector A dot vector B equals the magnitude of A times the magnitude of B cosine phi. Alright, since the product of scalar dot product of two vectors is scalar, so the product can be positive, can be negative, or can be zero. So how about in this case, letter B? Okay, we're done with this. About letter C, we're done with this. Okay, we're done with this. And then what if the angle between, alright, for in this case, the angle between vector A and vector B is less than 90 but greater than 0. Now, in the case where the angle between vector A and vector B is greater than 90 degrees but less than 180, okay, the angle is between 90 degrees and 180 degrees, then the scalar dot product of these two vectors is negative. Why? A cosine of an angle between 90 degrees and 180 degrees is negative. Alright. Now, if two vectors are perpendicular to each other, then the scalar dot product of two vectors is 0. Right? Why? Cosine of 90. What's cosine of 90? 0. So the magnitude of A times magnitude of B cosine of 90, which is 0, is equal to 0. Like we can apply this to finding work done by a force. Now, if the force is perpendicular to the direction of displacement, then the work done is 0. So again, if the angle of vectors between two vectors is 90 degrees, or these two vectors are perpendicular to each other, then the scalar dot product of these two vectors is 0. Because B has 0 component in the direction of A, as well as A has 0 component in the direction of B. Okay? So the quantity vector A dot vector B, we read this as vector A dot vector B, is scalar, which is vector A dot vector B equals AB cosine theta. Okay, so what do you think is the scalar dot product of two anti-parallel? If you consider, remember, anti-parallel vectors are two vectors that pointing in opposite direction. If vector A is pointing at that direction, then vector B must point at that direction. Though they don't have the same magnitude, but they are pointing in opposite direction. So what's the angle between them? That's 180 degrees. Right? What is cosine of 180? That's -1. So the dot product of vector A and vector B is negative, equals negative AB. y. Vector A dot vector B equals the magnitude of A, magnitude of B, cosine of the angle between them, which is phi. So AB cosine of 180 degrees. What is cosine of 180 degrees? Negative 1. So that's negative AB. So the scalar dot product of two anti-parallel vectors is negative AB. Now how about parallel? Two vectors are parallel, pointing at the same direction. If this is vector B and this is vector A, they are pointing in the same direction. What's angle phi equal to if they are parallel? That is 0. What is cosine of 0? That is equal to 1. So the dot product of vector A and vector B, if these two vectors are parallel, meaning pointing at the same direction, then that is AB cosine of 0. Cosine of 0 is 1. It's cosine of 0. Cosine of 0 is 1. Then vector A dot vector B equals AB. Alright. So if two vectors are pointing in the same direction, then the scalar dot product of these two vectors is the product of their magnitudes. Magnitude of vector A times the magnitude of vector B. Now, if two vectors are perpendicular to each other, let's say this is vector A and this is vector B, the projection of vector A onto direction of vector A is 0, and the projection of vector A onto direction of vector B is 0. So it means they are perpendicular to each other, and cosine of 90 equals 0. So vector A dot vector B is the magnitude of vector A times magnitude of vector B, cosine of 0. And what is cosine of 90? And cosine of 90 is 0. So multiply by any magnitude of vector A and vector B equals 0. Vector A dot vector B equals 0 if these two vectors are perpendicular to each other. This time we're going to calculate the scalar product of two vectors using their components. Okay, so I have here the x and xy z axis. Right, the unit vector along x axis is I hat, the unit vector along y axis is j hat, and the unit vector along z axis is k hat, and these three vectors are perpendicular to each other. J hat is perpendicular to y is perpendicular to x is perpendicular to z, and z is perpendicular to y. Z is also perpendicular to x, or x is perpendicular to y. And then the dot product of two vectors that are parallel, meaning they have the same direction and the angle between them is 0, equals 1. So the I hat dot I hat equals 1, j hat dot j hat equals 1, and k hat dot k hat equals 1. But the dot product of two perpendicular vectors is 0 since the angle between them is 90 degrees and cosine 90 is 0. So it means j hat dot I hat dot j hat equals 0 because they are perpendicular to each other, or I hat dot k hat, that is these two unit vectors are perpendicular to each other, then the scalar dot product is 0. J hat and k hat, j hat dot k hat is also 0 since they are perpendicular to each other. So we're going to calculate using we will calculate the scalar dot product using their components. Alright, so vector A as component ax I hat plus ay j hat plus az k hat, and vector b equals bx I hat plus by j hat plus az k hat. Alright, and then vector a dot vector b is just equal to a of x I hat plus ay j hat, and then plus a of z k hat dot, since that's that product, vector b of x I hat plus by j hat plus bz k hat. Right, so we'll distribute with a of x I hat dot b of x I hat. So we have this is equal to, I'll have more space. So vector a of x, vector a dot vector b will have a of x I hat dot b of x I hat. Okay, next, a of x times a of x I hat times by j hat dot b y j hat. Okay, then plus a of x to bz, or a of x I hat times bz k hat, so that's ax I hat then bz k hat. Then next is ay j hat to bx I hat, then that's plus ay j hat dot b of x I hat. Okay, then that's ay to b of x. Next is plus ay j hat dot by j hat. Okay, then we'll continue it here. Next is, so we're done with ay j hat dot by j hat, and next is ay j hat dot bz k hat. So you have ay j hat dot bz k hat plus, okay, so we're done with ay bz. So next is az to bx, so that's az k hat dot bx I hat plus, okay, az to by, we have az k hat dot by j hat, then plus, so we're done with this. Next is az to bz, so az k hat dot bz k hat. Alright, so if two vectors are parallel, so what is I hat dot I hat? We have equal to 1. So 1 times ax bx, so that's ax bx. How about this one? I hat dot j hat. They are the unit vector I and the unit vector j are perpendicular to each other. Then the scalar dot product of these two unit vectors is 0 times ax by, so this is equal to 0. How about ax I hat dot bz k hat? I hat is perpendicular to k hat, so the dot product of I hat and k hat is 0, so this is equal to 0. How about j hat, a y j hat and bx I hat? J hat and I hat are perpendicular to each other, then this is equal to 0. How about j hat and j hat? They are parallel. They have the same direction. The angle between them is 0, then j hat dot j hat equals 0. So we have ay by. J hat dot j hat equals 1, then multiply by ay by. So we have plus ay by. Okay, next, j hat dot k hat. These two vectors are perpendicular, then the scalar dot product is 0. About k hat and j hat, they are perpendicular to each other, so the scalar dot product is 0. K hat and j hat, they are perpendicular to each other, then the scalar dot product is 0. How about k hat dot k hat? They are parallel. The angle between them is 0, so cosine is 0 is 1, then we have times AC times BC, then plus AZ BC. Okay, so can you see any unit vector? There is no unit vector, so it means it has no direction. And the product of two vectors, vector A, so vector A dot vector B equals AX BX plus AY BY plus AZ BZ. Okay, so this is the dot product of two vectors, AX BX plus AY BY plus AZ BZ. So this is a scalar. So since vector A dot vector B equals AX BX plus AY BY plus AZ BZ, and by the definition of scalar dot product, the dot product of vector A is projection of vector A into the direction of vector B, or the projection of vector B onto direction of vector A, or AB cosine theta. So AB cosine theta is just equal to AX BX plus AY BY AC BZ. So what is the angle between these two vectors, vector A and vector B? Right? So since vector A dot vector B is this one, and also AB cosine theta, then AB cosine theta, theta here is the angle between the two vectors, angle between vector A and vector B. So that will be equal to AX BX plus AY BY plus AZ BZ, or cosine theta is AX BX plus AY BY plus AZ BZ all over the magnitude of A, magnitude of B. So theta as the angle between these two vectors is the inverse cosine of AX BX plus AY BY plus AZ BZ all over AB. So this is the angle between the two given angle vectors, which is the inverse cosine of AX BX plus AY BY plus AZ BZ all over the magnitude of vector A times the magnitude of vector B. So let us have an example of the dot product of two vectors. These are the two given vectors, vector A and vector B, right? Vector A is 3i hat minus 2j hat plus 4k hat, and vector B is 2i hat plus 4j hat plus 5k hat. And we need to look for the dot product of these two vectors. Then the dot product of these two vectors is a scalar. So expected that the product has no I hat, no j hat, and no k hat. Okay, so let's look for the dot product of vector A and vector B. And we know that the dot product of two vectors, vector A dot vector B, is equal to ax plus bx plus ay times by plus az bz. Right. So we have, what is ax? It's 3 times what is bx? That's 2 plus ay, that's negative 2. by is 4 plus az is 4 and bz is 5. Right. So we can now look for vector A dot vector B. 3 times 2, that's 6 plus negative 8 plus 20. So it's 6 plus negative 8 plus 20, negative 2, that's plus 20, that's negative, that's 18. Right. So this is the dot product of vector A and vector B. It's a scalar quantity. It has no direction. It has no unit vector. Right? So next, we need to look for the angle between vector A and vector B. Okay? So that, or the angle phi. We know that phi is the inverse cosine of ax bx plus ay by plus az bz all over the magnitude of A times the magnitude of B. We know what is ax bx plus ay by plus az bz. This is the dot product of vector A and vector B, but we don't have magnitude of A and the magnitude of B, so we need to look for the magnitude of vector A. Okay, so the magnitude of vector A is the square root of ax squared, so that's 3 squared plus negative 2 squared plus 4 squared, then that is 9 plus 4 plus 16, that's square root of 29. So we have magnitude of vector A, which is square root of 29. Next is the magnitude of vector B. Okay. B, the magnitude of vector B is the square root of ax squared, that's 2. So you have 2 squared plus the square of the y component, which is 4, so you have 4 squared plus the square of the z component, which is 5, so you have 5 squared. So the magnitude of vector B is 4 plus 16 plus 25, and that is the square root of 45. Okay, so that is the square root of 45. That is the magnitude of vector B. So we can now look for the angle phi, which is the angle between two vectors, or angle phi equals the inverse cosine of what is ax bx ay by plus ac bc, that is 18. The dot product of vector A and vector B. So you have 18 over magnitude of A, which is square root of 29, and then magnitude of B, which is square root of 45, Then let us solve using calculator. Cosine 11 degrees. Right. So we have angle phi as the angle between vector A and vector B. So this is the angle phi is the angle between vector A and vector B. And the scalar dot product of these two vectors is 18. Okay, so let us see if it is really 60.11. So I have here two vectors, vector A and vector B. So this is vector A. Okay, this is the x-axis. Vector A has x component of 3, a y component of -2, and then 4 units of z component. So look at here, that is 3. This is vector A, 3 units from the origin along x-axis. Okay, and then -2 units, so downward, -2 units. And then 4 units upward, that's for the z component. So this is vector A, right? And then vector B is 2j hat. Vector B, 2i hat, plus 4j hat plus 5k hat. So it means it has two x component of 2 units, y component of 4 units, and z component of 5 units. Right, so B is 2 units positive, okay, 2, and then you go upward, it has 4 units, so 1, 2, 3, 4, and then at this direction, going to z, positive z direction, that is 5 units on this one. Alright, and look at the angle between the two vectors. These two vectors, tail of these two vectors are at the same point. It is at the origin. And look at what is the angle between. That is 60. Right. The angle between is 60. A bit bigger. Okay. As you can see, the angle between is 60.11. Alright. So let us have another example of that product of two vectors. We have two given vectors here. Vector A is -3i hat plus 2j hat minus 4k hat. And vector B equals 2j hat plus 3k hat. So we need to look for vector A dot vector B, which is the scalar dot product, and phi as the angle between them, between vector A and vector B, right? So first, vector A dot vector B equals ax bx plus ay by plus az bz. Okay, so what is a of x here? A of x is -3, b of x is 0, there's no x component, and then plus a of y is 2, then b of y is -2 plus az is -4, bz is 3. Alright, so this is equal to 0 plus -4 plus -12. So we have it's -4 plus -12, -16. Okay, now if the dot product of two vectors is negative, what does it mean? Okay, if the dot product of two vectors is negative, then the angle between them must be greater than 90 but less than 180 degrees. Okay, so theta here, the theta phi as the angle between vector A and vector B must be between 90 degrees and 180 degrees. So let us see if it is really greater than 90 but less than 180 degrees by looking at the angle phi. So we have, but how? We don't know the magnitude of vector A and we don't know the magnitude of vector B. So we need to look first for the magnitude of vector A and the magnitude of vector B. So A is the square root of negative 3 squared plus 2 squared plus negative 4 squared. So that is the square root of 9 plus 4 plus 16. That is still square root of 29. Right? This is the magnitude of vector A. Double check. 3 squared, negative 3 squared, 9. 2 squared is 4. Negative 4 squared is 16. Then we have square root of 29. Next is the magnitude of vector B. What's the magnitude of vector B? The magnitude of vector B is the square root of 0 squared. It has no x component, so you have 0 squared plus negative 2 squared plus 3 squared. Then B, the vector B has magnitude of 4 plus 9, square root of 13. Okay, this is 4 and this is 9. Then we have square root of 13. So the angle phi is expected to be greater than 90 degrees but less than 180 since the dot product of these two vectors is negative. Alright, so let's see. So the phi is the inverse cosine of AX BX plus AY BY plus AZ BZ all over magnitude of A over magnitude of B. So that is equal to, what is AX BX plus AY BY plus AZ BZ? That is negative 16. So that's the inverse cosine of negative 16 all over the magnitude of vector A is square root of 29 and the magnitude of vector B is square root of 13. So let us solve using calculator. Alright, so phi is 145.49 degrees. That's the angle between vector A and vector B. So let us look at a graph of these two vectors. So this is the graph of two vectors. Okay, this is vector A. This is vector A, right? And we have vector B. So the tails of these two vectors are at the same point, which is at the origin. And look at what is the angle between them. That's 145.49 degrees, right? So that is example number 2. Okay, another one. Another example. Scalar dot product of vectors. Alright. So there are 4 given vectors, vector A, vector B, vector C, and vector D. And then we need to look for vector A plus vector B dot vector C minus vector D. What does this equation means? The dot product of the sum, it means the dot product of the sum of vector A and vector B and the difference of vector C and vector D. So we need to look for vector A plus vector B, and next is we need to look for vector C minus vector D, and the sum of these two vectors will be in dot product to the difference of these two vectors. So let us look first for vector A plus vector B. Okay, what is vector A plus vector B? Okay, we have vector A plus vector B, that's AX plus BX I hat plus AY plus BY J hat plus AZ plus BZ K hat. Okay. And then what is A of X? That is 3. What's B of X? That's 2. Then I hat plus AY. AY is negative 4 plus BY. BY is 2 times J hat plus what is AZ? AZ is 5, right? Plus BZ. BZ is 1 times K hat, right? So what is 3 plus 2? That's 5 I hat. What is negative 4 plus 2? That's negative 2. So that's minus 2 J hat. What is 5 plus 1? That is 6. So plus 6 K hat. So that is vector A plus vector B. Okay. Next is to look for vector C minus vector D. What is vector C minus vector D? That is vector C, that's CX minus DX I hat plus CY minus DY J hat plus CZ minus DZ K hat. Alright, so we have what is CX? Negative 3 minus DX, that is 1 I hat plus CY, that's negative 1 minus DY. Okay, look at the vector D, it has no Y component, so this is 0 plus CZ, that is 2 minus DZ, which is 6 K hat, right? So what is negative 3 minus 1? That's negative 4 I hat. Okay, what's negative 1 minus 0? So this is plus negative J hat, right? 2 minus 6 is negative 4 K hat, or negative 4 I hat minus J hat minus 4 K hat. So that is vector C minus vector D. So next, so let us double check. CX is negative 3 minus DX, which is 1. CY is negative 1 minus DY is 0. CZ is 2 minus DZ equals 6. Negative 4, negative 1, negative 4 K hat. Okay, so we can now have next is we need to do dot product of these two vectors. We have two vectors already. Alright, so let's get started. let's find the dot product of vector A plus vector B. The dot product of vector A plus vector B and vector C minus vector D, right? So we have vector A plus vector B dot vector C minus vector D should be equal to, what is the x component of A plus B? That's 5. So this is 5 times the x component of vector C minus vector D, that is negative 4, right, plus the y component of vector A plus vector B, that is negative 2, and then the y component of vector C minus vector D is negative 1, and then the z component of vector A plus vector B, that is 6, and then the z component of vector C minus vector D is negative 4. So we have 5 times negative 4, that's negative 20. Negative 2 minus times negative 1, that's plus 2. And negative 4 times negative 6 times negative 4, that's minus 24. So that is negative 42. So that is vector A plus vector B dot vector C minus vector D.